Well, welcome everyone to the day 2 of the Maps for the Web workshop, the joint W3C OGC Maps for the Web workshop. I'm Peter Rushforth, and very pleased to that you've all joined us today. We have a very tight schedule, so we'll be pretty strict about the times for talks. But before we get there, I would just like to mention that there are the few web links that we have to share, and we try to make the sessions as interactive as possible without running over each other. So we have a Gitter chat room that everybody should hang out in, and Ted will paste that link into the chat, has pasted it here into the chat. And each day I will post the slides and materials for the presentations shortly before the presentation, so as to not give the whole story away before the story is told. And then after the presentation, I'll create a discourse topic for discussion in the Web Incubator Community Group web mapping category. And if you have comments that could help, identify things that or any comments about a participant's presentation, that's a good place to talk about them, because browser developers hang out there and are sort of listening sometimes. And anyhow, it's a good place to chat about people's presentations. And I'd just like to remind everybody that we're operating under the W3C Code of Conduct, and Ted will paste a link to that as well. So if you have, basically it's all about professional conduct and interaction. So if you have concerns, please approach to any one of the conference committee who are online. And with that, I would like to introduce the agenda, our speaker agenda for the day. We're going to start off with Dr. Gobe Hobona of the Open Geospatial Consortium, who will speak about the global OGC APIs effort that is underway. And with that, I'll let Gobe share his screen, and I will put myself on mute, as I hope everybody else will.
Okay. Thank you, Peter. So I'll share my screen now. Can you see my cover slide?
Yes, I can.
Okay, all right, thank you. Okay, good day, everyone. So my name is Gobe Hobona. I work for the Open Geospatial Consortium, also known as the OGC. I'm going to talk to you today about OGC API standards for the web. I'll first of all introduce the OGC and then provide some background about OGC API standards, the development of those standards. I'll also explain some of the motivation behind the development of the standards and provide an overview of the OGC API standards. I'll also describe the innovation initiatives that we're using to support the development of the standards, and explain how anyone, any member of the general public can get involved in the development of those standards. OGC is a global consortium with more than 500 member organizations. Those organizations include commercial organizations, government departments, research and academic institutions. OGC provides a neutral and trusted forum for tackling interoperability issues. And OGC is a hub for thought leadership and innovation for all things related to location. There are more than 500 organizations that are part of the OGC, and those organizations come from the commercial, government, research, and academic sectors. Commercial organizations come to the OGC to improve their business development, to enhance their competitive technical advantage, to grow their global brands, and also to increase the likelihood of receiving innovation funding in the future from all the networking and knowledge transfer that takes place within the OGC. Government departments come to the OGC to improve their innovation and market support, to gain trusted advice, to expand their international partnerships, and to improve their operational policy support and certification. Research and academic organizations come to the OGC to expand their applied research partnerships, to improve their chances of receiving innovation funding in the future based on all the interactions with commercial and other organizations, but to also expand their international collaborations and increase their citations as well. So over the past couple of decades, OGC has developed a suite of standards. Some of those standards deal with OGC web services. Some of the more popular OGC web service standards include the Web Map Service Standard, also known as WMS, the Web Map Tile Service, also known as WMTS, the Web Feature Service, also known as WFS, and the Web Coverage Service, also known as WCS. These standards have been used in areas such as geology, transportation, city management, environmental data management, hydrology, and other areas. There are currently more than 200,000 OGC web services deployed across the web. So about 5 years ago, OGC started looking into the relationship between representational state transfer or REST approaches in relation to OGC web services. And what you can see on the slide right now is an analysis conducted in 2015, which related characteristics of REST approaches, which is what you see on the far left column, in relation to OGC web services, which is what you see on the right-hand side of the slide. So in 2015, OGC conducted research comparing REST to classic OGC web services. And then in 2016, the focus shifted from REST to web APIs. In 2017, OGC published a white paper on open geospatial APIs. Then in 2018, work on version 3 of the web feature service started. In 2019, the WFS3, or the version 3 of the web feature service standard, was renamed and called OGC API features. And that was in recognition that the approach that was being adopted by WFS3 was offering a new paradigm within the OGC suite of standards, or the OGC standards baseline. Then by the end of 2019, OGC API features part 1 was published as an official OGC standard. So why are we concerned with OGC APIs? Why are we developing these OGC APIs? Well, web APIs are a very popular and effective method for rapid software development. And what we have found is that with the proliferation of web APIs, the variations in those web APIs has to an extent degraded interoperability. So open standards are being developed to enable interoperability between independent implementations, and OGC APIs are being developed with a view of improving geospatial interoperability between web APIs. And there are a number of principles that the OGC is using to develop these OGC API standards. Some of the principles are shown on this slide. First and foremost, the OGC API standards are being developed to offer modular API building blocks. Those building blocks will spatially enable web APIs in a consistent way. And we're using a number of principles and approaches identified in the Spatial Data on the Web best practices, which have been developed jointly between OGC and the W3C. OGC API standards leverage the OpenAPI specification, specifically to help describe the APIs themselves, as well as implementations of those OGC APIs. Another key principle is that the OGC APIs are being developed to be as developer-friendly as possible. So there's a specific focus on developer experience and usability. And we're doing all of this development work publicly on GitHub, on a public repository. We're using early implementations of the OGC API standards to involve the general public using initiatives such as sprints. And we're using that to solicit feedback from the public and to use that feedback to help us validate and improve those standards. Another key principle is that of API first. So we're using an API first approach to develop the OGC APIs using OpenAPI, the OpenAPI specification to describe those APIs. And this enables us to describe in a machine readable way the resources offered by the API, the behavior of the API, as well as other aspects supported by the OpenAPI specification. So what are those OGC API standards? So we have the OGC API features standard. So this is a fully fledged OGC standard. Part 1 of the OGC API standard was published towards the end of 2019, and work is ongoing on developing additional parts and extensions to OGC API for the OGC API features standard. There are also a number of other OGC API standards that are currently under development. For instance, OGC API Common, which provides a series of requirements that are applicable across all OGC API standards. We've got OGC API coverages, which deals with access to coverage data, such as raster imagery. OGC API records, which deals with access to metadata. OGC API processes, which deals with access to geospatial processes, such as buffering, routing, hydrologic models, and so on. OGC API Tiles, which deals with access to tiled resources, such as vector tiles, tiled raster coverages, tiled maps, and so on. OGC API Maps, which deals with access to electronic rendered maps. OGC API Environmental Data Retrieval, which deals with access to environmental data such as meteorological and weather data. And then we also have OGC API Styles, which deals with access to portrayal information such as styles and symbology. And we're also working on a number of future concepts, for instance, an API for discrete global grid systems, as well as another for routing. Now, what can you expect from each approved OGC API standard? You can expect a standards document and an OpenAPI definition document. You can expect an executable test suite to help implementers validate whether or not their implementations comply with those standards. And you can also expect tutorials and guides. What you can see on the screen are examples specifically focusing on OGC API features, which provides access to vector feature data. And we've set out a roadmap as shown on this slide with a number of the standards planned to be published by the end of this year, as well as others that will be published in 2021. Another thing you'll notice from this slide is that many of the standards are being developed as multi-part standards. What this means is that there's one core specification as well as a number of extensions all within the same standard group. And we're using a number of innovation initiatives to develop these standards. Examples include sprints, hackathons, pilots, testbeds, as well as others. What you can see on the slide are some of the innovation initiatives we've held since 2019. We held a hackathon in London in June 2019, and we had about 70 participants literally participating from across the globe. We've held several sprints since then. And next on the calendar is a virtual code sprint on September 29th to the 30th, which will focus on the OGC API Common and OGC API Features standards. In order to participate in the sprint, you'll have to register at this URL shown on this slide. And that's it. If you have any questions, please feel free to send an email message to the address shown on this slide. And you can also visit the ogcapi.ogc.org website where you'll find information about OGC APIs as well as initiatives that we're planning to develop those standards. And that's it. Thank you.
Great. Thank you very much, Gobe. It's a monumental initiative with lots of moving parts, and it's pretty interesting to see it move along. Well, I'd like to introduce our next speakers then and keep things moving here. So the next talk will be about pygeoapi, which I believe is an OGC API implementation by Tom Kralidis, Angelos, Tzotsos, and Francesco Bartoli, who are all present today. So with that, I'll let Tom take the lead, and please welcome them. Tom, I think you're on mute.
Oh, thanks. Sorry, can you hear me?
Yeah.
Can folks see my screen?
Yep.
Excellent. Okay, so thanks for the introduction. We will give a small presentation today on the pygeoapi project. So the pygeoapi project is a OSGeo community project, and it currently implements many of the OGC of the evolving OGC API standards. It is a reference implementation already for the OGC API feature standard. So. So I'm just going to give an overview following on from Gobe's presentation around, I won't get into all of these because they sort of echo what Gobe is saying, but I'll talk a little bit about the project itself, some of the core capabilities, as well as example of production instances and where we're hoping to go moving forward. So the project was created in 2018. So as Gobe mentioned, there was some initial work on code sprints and hackathons around WFS3, which it was called at the time. So we participated in that sprint and have been participating in the subsequent sprints from OGC on OGC APIs. So the project has been around for a couple of years. We designed it sort of as a geospatial data API framework where it could be very extensible and is available through numerous web front-end technology approaches, at least for Python. And we really wanted it to be extensible on the back end to be able to integrate many different formats or other services. There's a growing international team. There really should be a map here, I guess, but there's a growing international team from many countries and time zones. So the meetings are always interesting to schedule, but it gives you an idea of the participation and the widespread interest in these evolving approaches. And we're happy to have everybody contributing that already is. So again, it's an OGC API server implementation in Python. It publishes data, so we don't really get into massaging data too much, but it's basically a data publishing tool. And it leverages the powerful ecosystem of Python packages. So for those who are familiar with Python, there's a huge ecosystem of geospatial tooling underneath, and pygeoapi is basically a shim on top of all of that to be able to provide this functionality. So you can run pygeoapi from the command line, or you can run it from a web application. I'll just give you an idea of the overall architecture of the implementation. So we have a core, which is our core sort of Python API, and then we have a series of web front ends. So if you're familiar with Python web frameworks. They're available in Flask and Starlet and other frameworks. If you have your own downstream implementation, you can use pygeoapi as a library and deploy it alongside your own implementation. So again, we have a very small but robust and flexible core, and which is made available through these web APIs. And that core itself takes a number of different backends or formats or databases or search index through these data provider plugins. So we have a plugin mechanism for the entire project where you're able to plug your data into the pygeoapi framework, no matter where it sits or how it's sorted out. As long as you implement the API accordingly, then you'll be able to publish your data through pygeoapi, thereby satisfying the OGC API standards. There's a number of different backends already out of the box, so some of you may be familiar with some of these, but we do also support the GDAL underlying software, which reads hundreds of different formats. So if your geospatial data is compatible with GDAL OGR, it's automatically compatible with pygeoapi, and you can put it out to OGC APIs quite easily. We've recently implemented the support for coverage data providers. So those of you who are into grids or raster data or multidimensional data, Earth observation data, this is now possible through pygeoapi and the evolving OGC API coverages specification. So really exciting stuff here. We've recently implemented in terms of tiles. So we have the ability to connect to a directory structure for tiles or object storage, local or remote. We'll talk a little bit about that later. And we also implement the schema.org sort of link data approaches to make resources available through pygeoapi, search engine friendly, and discoverable through mass market approaches. So I'll walk you through some screenshots in terms of capabilities. So here's a default view of when you stand up a pygeoapi instance. You get a web presence, and as Gobe may have mentioned, the HTML or web page capabilities in OGC APIs is a desirable thing for mass market integration. So here's an HTML view of the landing page for a pygeoapi implementation. Here we can see, you can browse the, what kind of collections are configured, what processes are available, how a developer can interact with the API through the API definition, as well as a conformance page to find out what standards are implemented. Here's our OpenAPI page. So API first approach, you can walk through all the different endpoints and find out more about what parameters are accepted, what their data types are, what a response looks like, and so on. Here's a screenshot around OGC API features. So this is showing some lake data. We've recently implemented in the last month or so OGC API coverages. So that was provided by USGS into the project. So we're appreciative of that. So there you can see an example of some global temperature data, which is provided through OGC API coverage in the coverage JSON format, and then we can see a map there of the data. Fresh off the press, we've just implemented OGC API Tiles. So Francesco, who's on this presentation, recently implemented that. So that's a valued addition, and thank you very much for that. But here's what we were talking about around publishing tiles to pygeoapi, whether they're local tiles or whether they're available remotely through object storage, as well as OGC API processes. So you can configure any kind of process that you want, whether it's synchronous or asynchronous, using the pygeoapi framework and making that available through OA proc. Finally, we have implementation, we have support for the spatial temporal asset catalog, or the stack implementation, which allows for a browsable catalog of geospatial/temporal assets. So you can drill down directory trees of geospatial data and then get to the actual files, peruse and see what they look like, and then download them if you wish. So that's a little bit of an overview about what the project is all about, how it's sort of set up and what its core capabilities are. I'll walk you through some examples of production instances. So we here at the Meteorological Service of Canada have deployed pygeoapi as part of our national geospatial API weather, climate, water API platform, which is called GeoMet. So we provide real-time weather data from numerical weather prediction, as well as hydrometric and climate archive data. So we initially used pygeoapi to provide our climate, our hydrometric and our climate data through the OGC API feature standard, and that's made available through geo.weather.gc.ca, as you can see there. So you can go to that link and look at hundreds of years of climate archive data in the WFS3 format. We also implemented a data extraction capability through OGC API processes, which basically looks through simulations of climate data, forecast data, and extracting time series out of those, and basically providing time series extraction from a coverage into a CSV or a GeoJSON. We are looking at providing more support, more pygeoapi capability through our platform. So we're looking into doing things with coverages, as well as the evolving OGC API records standard. There's also an implementation from the Global Soil Information System by UN FAO. So they've provided a lot of work and examples on doing JSON LD in pygeoapi. So you can click and visit that website when you have a chance. And finally, roadmap. So I think the project for just over 2 years has implemented quite a bit, and there's been a lot of rapid development. And I think this is very telling of the OGC API efforts and the goals of lowering the barrier for developer implementation. So this very quick uptake to this project by an increasing number of developers, and I think that's a core reason why. Having said that, there's still more work to do. We're looking to, given the OGC API standards development efforts are public, we are, sort of moving along with the evolution of those standards. So we're looking to implement maps, tiles, and records as part of a future implementation. And we're always improving the API support. And the next one we'll be improving is the processes support, with some of the updates that have been going on in the processing standards working group. More data providers. So we want to provide as flexible a capability for people to hook up their data as possible. We recently had Google Summer of Code contributions from 2 students to provide capability on supporting the Common Query Language or SQL standard, as well as doing transactions. So create, update, delete. We're looking into better content negotiation, as well as spreading the project through more approaches. So OSGeo Live is a live DVD or a live implementation that you can download and run all of the OSGeo sort of software, free and open source geospatial software. So that is a very popular implementation, and we're looking to get our software onto that to be able to spread the news about the project and make it more easily available to as much people as possible. And there's a variety of support mechanisms that if you're looking for support through these various organizations, we have We have a Gitter channel that folks can come in and ask questions. There's a mailing list. There's documentation. You can peruse all the links as you wish there, and that's pretty much it. So thank you for listening. And unless Angelos or Francesco has any comments or things to add that I may have missed, I'd like to thank everybody for listening.
Thank you very much, Tom. If we have time at the end, and Francesco asked if we could see a demo, and we'll just keep a close eye on the clock and see if that's possible. But thank you very much. It looks like a very interesting project and something that pretty much anybody's in geospatial could use. So with that, we're going to move on to the next next talk in our agenda, and with thanks to Heather, our closed captioner, for her great efforts so far, because we're really making them work hard today. So I'll pass the control over to Joan Masó, who will talk to us about the connection of the MapML initiative with OGC standards, such as the new OGC API Tiles talk and the OGC WMS. So, Joan, are you unmuted? I'm not hearing Joan.
I believe now I'm
Now you're good.
online.
Okay, off
Yes.
you go. Thank you.
Okay, thank you for presenting me. I'm working at CREAF here in Barcelona. Always close working with the OGC, with different standards evolving. Let me just start by saying that there are several ways that you can send from the server to a client a map, and they have different levels of complexity. The most low-level thing that you could do is to package some kind of a description of the geospatial objects or maybe the pixels from the server, invent some kind of a protocol and send it to the client. You could also think about creating some kind of a JavaScript code that will allow you to manipulate data and to present it into the screen. Or you could think that HTML could actually be able to do the mapping thing by itself. And we all know that MapML is precisely that approach. But I wanted to present that in perspective, because actually the first approach is what OGC Web Services has been doing for more than a decade. This idea of having this key value per request and then this response with a geospatial format into the client that will be able to present that. We are now transitioning into this OpenAPI world. This is going to make some of these things a little bit more easy, because, for instance, we are changing from XML to JSON that works more naturally into the web client. But essentially, we are kind of doing the same thing. In the JavaScript world, you can use Leaflet, you can use Google Maps. You know the experience of doing that. It's easier. And in the low level, in this down level here, we have the MapML. A MapML is just some elements into HTML page that you could use to actually communicate the map to the client. Actually, the OGC has a standard that is called OWS Context that enumerates a set of resources that you can see together in a client that plays a similar but different role. Is not, of course, an extension of HTML. Is actually an atom encoding. So if we can discuss a little bit these 4 levels, let's say that in the first level, it is kind of a good way of doing things for desktop solutions, for communicating services among them. But it's difficult to do that in the browser because you have to manually build JavaScript code that builds these get KVP request, interpret the response, maybe a GML, maybe a TIFF file, something like that, and then create some HTML content using this JavaScript in order for the user to actually see something. Maybe you could use Canvas instead, but the idea is the same. With the approach of OpenAPI, this is number 2 here in my slide, you can automatically create some content, some code from the OpenAPI document. You have the ability to parse automatically JSON from JavaScript. That's something, but still you need to manually extract and show the information that it's actually great for maximum flexibility and for combining several services together, but it's complicated. We all know that you can take leaflet if you know a little bit of JavaScript. You can simply program using some sentences here and there in your HTML page, and it's reasonably easy to do at least the minimum map visualization. But with MapML, you have simply tags. You have elements that you add into your HTML describing what the map should have, not how it should be presented, but what is it. We have been exploring for more than 4 years now the relation between the OGC standards and the MapML standard, and I have collected these experiences of the different test beds, and you can visit this URL there on the right hand side, sorry. And it's difficult to summarize, so I will say that in 17, what we did was to do our first experience, and we compare MapML with OWS context. In 18, what we did was to suggest that MapML should include URL templates, and actually this ended up into the MapML specification. In testbed 15, what we did was, for instance, suggesting that OGC API features could negotiate MapML content in the items part of the API implementation. And in 16, in the testbed 16, that is currently happening, we are more focused on building clients that could show inputs of machine learning processes. From my point of view, and I'm biased, it's all about tiles. So OGC and MapML share exactly the same tile model. In OGC, it's called tile matrix set. In the MapML, it's called tiled coordinate reference system, but it's kind of the same. MapML defines 4 tile coordinate reference systems, while in the OGC, you could define the tile matrix set that you like as far as you are able to describe it. Actually, we make an effort to allow for 3 of the 4 TCRSs in MapML to be also in the OGC standard called two-dimensional tile matrix set, an XD. And those are the equivalences between the MapML names in the left-hand side and the OGC names in the right-hand side. Tile sets. So we are talking about tile sets. We are talking about collections of tiles that are going to be partially presented to the user and will be kind of automatically replaced by others while user pan and so. Those tile sets are represented by URL templates, both in OGC API Tiles and in WMTS, as presented by Gobe before, and also in MapML. So the same URL template is useful. There you see the representation in the OGC OpenAPI 3.0 representation, and you see it below in a MapML document. I took the liberty to actually replace the X, Y, and Z variables by the variables that usually use in OGC. I believe I'm not violating the MapML standard by doing that, and this looks more similar. So actually, in MapML, tiles are used, but MapML doesn't specify how you will produce them. In MapML, there is no specification on how you will produce a MapML document. It's just telling you how a MapML document should look like. On the other hand, in the OGC API tiles, a collection can be distributed as tiles. So each tile could be available as a URL responding to the URL template. And in the OGC map tiles, there is a new thing that is called the Tileset metadata document that is going to be explained after that, and I will try to convince you that actually the MapML is a Tileset metadata document. First, let me say that in the OGC API tiles, we have several resources that are listed here. The last one allows us to connect or to transform a collection into tiles. But what I would like to present to you is this Tileset object. And this Tileset object is in this particular path of the API representation. It returns a JSON document describing the tile set, a bit of metadata, a tile matrix set definition, a tile matrix set limits, a URI template, and maybe some description of the content of the tiles. And this is a UML diagram of how it looks like, but actually, as I said, is going to be a JSON file. But if you try to compare that, a MapML is actually something that does a very similar thing. It provides some bit of metadata, a title there. It points to the tile matrix set definition, OSM tile in this case. It states some limits. For instance, the maximum zoom will be 15. And it points to a URL template, as I can see there. So, I mean, the similarity is so clear that actually I manipulated the OGC API tiles example that I'm using in GitHub, in the Swagger Hub, just to tell that actually, apart from the JSON representation, we could have a MapML representation. Sorry, because I cannot use the actual media type for MapML, because then the Swagger Hub doesn't recognize that this is XML, but or micro XML. But you see, this is a new connection that we are seeing that really makes this relation between MapML and OGC API tiles possible. So in conclusion, MapML is the simplest way for adding geospatial information in web browser that I know. And MapML makes use of the OGC or can make use of the OGC API tiles to make the OGC API tiles use simpler in browsers. So it provides a way to communicate two of the API resources, the tile set and the URL template tiles, to the browser itself. So the OGC API tiles provides a way to automatically generate MapML documents, or at least there is a resource that could have a representation in that form. And the OGC API tiles could become the CGI of the MapML form. So actually, what I'm suggesting here in this presentation is that the OGC API tiles part 1 should consider to describe how to generate MapML documents as an alternative format to the current JSON tile set metadata that is on the OGC to the tile matrix set standard. Actually, we are also considering another alternative format for vector tiles, for Mapbox vector tiles, that is called Tilesets. So thank you.
Thank you very much, Joan. It's very interesting, and would be great to connect the monumental effort of the OGC API work with the browser community through a media type. So with that, we'll move on to Jonathan Moules of GeoSphere, which is a geospatial web services search engine, and he's got a few points to make about his experience in developing that search engine. So Jonathan, thank you very much, and I'll pass it over to you.
Hello world, can you hear me, Peter? And see me? Or see the screen anyway?
Mm-hmm.
It's all good. Excellent. Thank you. Hello, everyone. Welcome to Edinburgh. Imagine you're here, grey sky, grey buildings. That's Edinburgh. They're very nice buildings, to be fair. So we've set the scene. I am here to talk to you about some of the limitations to the use of OGC spatial web services. Specifically, the discovery problem. How do you find these services? What's the point of having all these services if you can't find them? To wit, I've created GeoSphere, which is a search engine for such services. And then some thoughts and conclusions around such finding these services and what the problems currently are. So, the discovery problem. Let's just do this a second. Wrong one. Yeah. So, oh, we've lost a page. So specifically, we're talking about these services: WMS, WFS, WMTS, WCS. Gobe has already talked about them. They're all OGC services. They're all lots and lots of them on the internet. Question is, how do you find them? You could try Googling, but it's difficult. There are lots of portals. So the primary way to really find these things is with portals. The problem with portals is there are a lot of them. So I'm aware of about 200 CCAN portals and 150 CSW portals. There is some overlap between them, but the short version is there are literally hundreds of these. On top of that, you've got Inspire portal and then all the ArcGIS ones as well. There are a lot of them. And the interesting thing about these is they don't actually have many of the services on them, but we'll get to that in a bit. So that brings us on to GeoSphere. GeoSphere is designed to help you try and find services. Great. This isn't actually a talk about GeoSphere per se, but the data that I've discovered, or we've discovered from the creation of GeoSphere and that GeoSphere allows us to see from having this huge index of these services. So GeoSphere is a search engine for these services. The way it works behind the scenes, very short version, it goes out, finds get capabilities documents, which all of these services present. It scrapes them to extract all the metadata, all the metadata that's there, optimistic right there, and turns it into basically this Elasticsearch database behind it, and makes that searchable. Great. So, what are the results of that? Well, GeoSphere has behind it, or has managed to find 5,000 different hosts of data. Now, a host is basically a domain name, example.com, arcgis.com, 2 different domains, 2 different hosts. USGS is 1 host. USGS.gov is 1 host. I forget off the top of my head whether subdomains count as a separate host, but either way, there are 5,000 of them. As you can see here, this is data from December. Actually, so there's even, well, it's about the same number of hosts now, but more data sets. So you've got 5,000 hosts.
John, are your slides advancing?
They should be. Which one are you looking at?
We're looking at the WMS, WFS, WMTS, and WCS slide.
Oh dear, computer's broken. Yes, I've got a few slides. Let's just stop the screen sharing and restart it. Bear with me. Have I progressed? Has it changed?
Yeah, we
Excellent.
can see portal type.
Excellent. So yes, this is what I was talking about when there are like 200 portals, and so you've got your 200 CCAN portals and 150 CSW portals. This is just screenshot GeoSphere when I was talking about that. Get capabilities document, it's just XML. Everyone loves that. So this was the one I was just talking about.
Maybe I think when you go into full screen mode, it's not advancing. Maybe you should just do it in edit mode.
Yep. There we are. Is this better?
Yeah.
LibreOffice seems to be quite broken for presenting stuff. Ironic, given it's open source. Big fan of open source. Is this better? So this is hopefully showing you the number of hosts and number of services and stuff. Yep, good stuff. So, yes, sorry, where was I? Good thing this is a lightning talk, so I've got spare time for technical problems. The number of, and you can see the weirdness that's going on there with open, I don't know. Anyway, technology, right? That's what we all do. The number of hosts. So we've got 5,000 on GeoC. You can see that if you look at all of the CCAN portals minus the USA one, because it's different because it is, you've only got 5% of the total number of hosts, and about 3% of the total number of data sets are available via all of those 200 CCAN portals as compared to being on GeoSphere. You know, CSW, 6%. So even if you were to manually go through those 350 portals, you would only find a small fraction of the data that is actually out there. Now, all of these numbers are services that are actually out there and actually live and actually current. So they should respond. They did respond to a get capabilities request, so they're actually there. The stuff on the portals, of course, don't necessarily always have current live data, so the actual number of claimed hosts may be higher, but this is the number that's actually there. So you can see the problem with portals is, well, they don't really have much on them. And of course, there are so many. So there's an entire blog post about it. Oh, wrong button. So let's move on to other problems. Metadata. Everyone loves talking about the fact that no one fills in metadata. This is the only slide on it, but the short version is they really don't. If you actually look at, so the blue bits are decent metadata. That's about 50 characters, 10 words.
Sorry, John, the slide for mine is still on number 9.
Number 9, oh dear, what is going on here?
It might be best to export it as PDF and then show the PDF instead.
I will try that instead.
Well, actually, now you're on 10 according to my screen.
Brilliant. Okay. Yep, so 10 is the dataset metadata. We'll just keep going on this. Tell me if it doesn't update. I'll tell you when I do the next slide. It's all part of the fun. Dataset metadata. So basically, no one fills in. For WMS, there's barely any metadata filled in for the abstracts. Less than half of the services have any metadata filled in for the abstract. So how are you going to find these services if they're out there? It's just not there. Next slide. Hopefully a map.
Nothing yet.
I'm going to click around a bit and hope.
There you go. Yeah, got a map.
Yeah, I have to click a lot apparently before Zoom picks it up. Yeah, so this is global coverage of where all these data sets are. Mostly Europe. This is just a map of interest. Mostly Europe, quite a few in North America. There's a hotspot over the Belgium, France, Germany tri-point. But there are more of those maps, more detailed without the hotspot. That URL. So next slide, gonna click a lot.
Here we go.
So GeoSphere usage. So despite GeoSphere having a huge number of index of being completely free to use, doesn't even have adverts, there's actually very little uptake of it, which indicates there isn't much call for searching for these services in the first place. So we've got 2 million data sets, and GeoSphere only gets around 1,500 searches per month. So all of these data sets are out there, they're all published. Huge amounts of money have been spent to publish them, not just collect them, but publish them alone, Inspire, for example, the end result is there doesn't seem to be a huge amount of uptake in actually collecting, in people finding these data sets or being interested in finding these data sets. Which brings us on to the conclusions. I'm going to go around there. We are, hopefully. Thoughts and conclusions. The obvious one, people are terrible at filling metadata. Surprise. There doesn't seem to be much call for service and data discovery. It's a problem that's been solved on and off for the last 15 years. Most of the services that have ever existed doing it are now defunct.
Jonathan, I don't think the slide advanced.
No? This is just thoughts and conclusions. I'm effectively reading them out. So you're not missing a huge amount. Yeah, Zoom plus LibreOffice is not a combination you want to use. Zoom on Firefox, so it's like the open source option. I don't know. Anyway, federation of data portals is a great idea, but the end result is you just end up with far, far too many data portals, which themselves don't necessarily have much data on. And the question that I suppose I want to ask or to put forward is how many of these services exist for the purposes of sharing data, as in just to share it, and how many exist just to host data for their own data portals? So if you build a web app, you happen to come with, the web app happens to come with the WMS, that's built, that's just deployed for its own portal, as compared to ones that are explicitly designed for, here's all of our data, have at it. It doesn't, even if there is much of that explicit sharing, there doesn't seem too much explicit usage based on GeoSys search usage uptake. That's me. One very exciting presentation filled with lots of entertaining bugs of the technical kind, because well, if you're not working, you're still going to get bugs. Yes.
Thank you very much. I mean, aside from the technical bugs, which are always a bit confounding when you're live for the presenter, but not so much for us. I mean, I think we got the idea. You've presented some very interesting food for thought, and thank you for that.
Thank you.
So with that, I think what I'll do is, since it's 9 a.m., Ted, do you think we have time for a short demo from Francesco and Tom, and before we move into our panel situation?
Let's give it a shot.
Okay, so
squeeze the panel a few minutes if necessary.
Yeah, true. Probably the panel is not going to go too long. All right, so Tom and Angelo and Angelos and Francesco, could you? One of you share your screen and give us the demo that you were proposing?
Yes, sure. I'm going to share my screen. Just a moment. Sorry, I don't find the right. Hello? Are you seeing my screen?
Not yet.
Peter?
Hello? No.
Do you see my screen?
No.
I'm sharing.
Okay, now I am.
Okay, cool. Now, this is the landing page of pygeoapi. This is a local, obviously this is a local instance, just to give you a more detail about the explanation from Tom. We have two resources. One is the now famous large lakes. The lakes resource, the lakes layer, has two kind of specification under the providers. One is the feature, the OGC API feature, and the other one is the OGC API tiles. As you can see here, the actual data for the OGC API tile endpoint comes from a local instance, a local object store provided by a Minio server. So we have a Mapbox vector tileset loaded into an object store and provided locally to configure it to the PyGeo API. So essentially from the landing page, we can go through the collection. We can explore all the collection in this instance. And if you go over the large lakes, here there is an introduction HTML. This is the HTML representation, but essentially on the link in the upper right side, we have also the JSON representation and the JSON LD. So essentially, if you want to go to the actual vector tiles representation for large lakes, we can follow these links, and we open up the HTML representation on the maps, which dynamically load and proxy the vector tiles, so the Mapbox vector tiles, which are provided by the backend server. And from here, we have also the metadata representation in the tile JSON format. So if you go to that link, a new HTML page is shown, and obviously there is also its JSON representation. And just to reinforce the concept that Joan told you before, there is obviously here the JSON representation of the vector tiles endpoints. So here you can have the actual URI template with the different tile matrix set ID, and where that tile matrix set ID resides in terms of actual JSON content. Then I think for what regards the maps, I think it can be all. Apart from that, obviously we can go through the also to the actual OGC API feature HTML representation. Here you have an overview already provided in HTML map, and essentially a nice HTML representation of the records, and all of these can be also called as a JSON representation, which provides the feature, so as a GeoJSON with a feature collection payload. I think it's that's it. I don't know if there is some question about pygeoapi in general or the vector tile implementation. I'm open to answer. I don't hear you, Peter. I'm going to stop the sharing.
I think you are muted.
Also not hearing Peter. But next up we have Doug Sheppers and his panel on the wrong one, sorry. No. Well, actually, it's Peter's panel, so we kind of need him. Government stakeholders. Peter?
So Peter, maybe it's the microphone selection thing.
Peter, we seem to have lost your audio again.
Yeah,
There we go.
Okay. Okay, so we're going to go over to our panel now of stakeholders for government geospatial data providers on the web. And we have from the National Center of Geographic Information in Spain, Emilio López Romero, and from the Canadian Geospatial Data Infrastructure, we have Cameron Wilson, I hope, and Sébastien Durand from the Canadian Federal Geospatial Platform, and Don Sullivan from NASA. And so what I'd like to do is to ask each of them, starting with Sébastien, to introduce themselves and tell us a little bit about their background and their potential use of maps for the web, maps in HTML, and anyhow, I'll leave that up to you guys. So, Sébastien, over to you.
Well, thank you. First, I'd like to thank everybody on the phone or on the line today. I'm really pleased to be part of that workshop. I think it's a perfect setup for the Canadian Geospatial Platform. It's quite in context, so I just want to say big thanks, and I'm quite amazed with the pertinence of the conversation that has been happening so far. So kudos to all. So myself, I'm a geoanalytics team manager within the Canadian Geospatial Platform. We are within the Natural Resource Canada, obviously for the Government of Canada. Part of my general responsibilities are to provide products to the different clients we have. And it does provide over time a lot of expertise, and not expertise, but a good sense of what are the requirements of all the geo people who have interest in geo or need maps, for example. So just going back to the Canadian Geospatial Platform itself, we are an organization that aims to geo-enable the government. And what we did find is lately, I mean, while the platform has been actively onboarding data from diverse level of jurisdictions, being from federal, provincial, and territorial sources, the platform is also working at improving its web presence. The Canadian Geospatial Platform did realize how crucial it is to facilitate search discovery and visualization through the web. I mean, nowadays, even in COVID situation, we realize that the web is gaining even more precedence. It's the primary mean of communication. So it is really at the front end and how we disseminate content. So that's crucial content, crucial element to consider. So now with the GeoLens, information from all fields definitely can be integrated to provide insight through both space and time. And I guess that's everybody around the table has figured that. But there's actually a magical feeling when we see information of interest that is viewed and put into context on a map, not only because it provides a unique experience allowing the user to understand the situation, but also because it provides a feel of a common operating picture to all users. That is the true value of a geo product. It transcends all the different spheres in which the information has been gathered from. You can put it all together. So if effort is put into any product, you can officially provide a common operating picture. That means provide tangible information in a simple fashion so that people can consume it. And there's no real, there's no equivalent to such type of a capacity. So until now, I mean, experts have been using scripts, search engines, optimization, APIs, along with advanced software to make and publish maps. But I think we have to ask ourselves the following question is, whether or not does this make the geoinformation truly available, accessible, and consumable? Nowadays, I guess the web is the primary mean of expression, like I mentioned before, and HTML is obviously at its core, and it does act as a lowest common denominator. Because we see that over 90% of the newly acquired data now possesses georeferences down to just images that you take with your phone, it makes logical sense to see that this community investigate and address how can the act of mapping be made more accessible to all HTML users directly from their browsers as they actually code their page. So I think that is providing a bit of a perspective that is both mine and that of the FGP or Canadian Geospatial Platform. And I'll be happy to answer any other questions or give some further insights or maybe address some challenges that we may have if that's of interest to the panel. Thank you very much.
Thank you very much, Sébastien. So I'll pass it over to Emilio López Romero from the Inspire Initiative in Spain. Thank you and welcome. I'm unmuting you.
Okay, thank you, Peter, and thank you for the opportunity to participate in this panel. My name is Emilio López, Director of the National Center of Geographic Information. One of the main goals of my institution is the coordination of the national spatial data infrastructure of Spain. There are several organizations involved at different administrative levels, national, regional, and local. And I think that it's important to notice that in Europe, the member states has to fulfill the requirements of Inspire Directive of the European Commission, establishing a SDI for Europe consisting of national SDA and aim to facilitate the decision-making process regarding environment. Hence, standardization, harmonization, and common specifications have become not only mandatory, but crucial for us. Since we are providing with web map services, achieving 80 companies use our services has been an important challenge, even though they are free and open. Therefore, filling the gap between our services, web map, web feature, web catalog services, and web developers is vital, and OpenAPI new OGC specification and map features on the web at fundamental level will be part of the solution, I'm sure. I have I would like to say that 1 out of 4 maps that are downloaded using our platforms are downloaded via web services. And other important aspect, because there are several administrations using our web services, like the Cadastre Department of the Agriculture Ministry, perhaps the most important clients we have. But our feeling is that the private sector is not using our free and open resources enough. Thank you. This is what I would like to say at first time.
Thank you very much, Emilio. That is interesting. It aligns with some of the things we've talked about today. Now I'd like to introduce Cameron Wilson of the Canadian Geospatial Data Infrastructure and let him speak for himself. Thanks, Cameron.
Welcome, everyone. My name is Cameron Wilson. I work with Natural Resources Canada, and I've been working on spatial data infrastructures for going on 20 years now in a program called the GeoConnections program. I'm a manager in that program. And we've been doing a lot of work on standards in the Arctic and in Canada's geospatial data infrastructure, and also trying to incorporate both marine and land-based infrastructures. My formal training is as a geographer, and as part of that training, everything has a location and everything is in time. That's one bias I sort of like to declare right off the bat. And so this lends itself well to when we're having these conversations about being more integrated into the general web environment of the world and having that value of location and time. Also, another bias I like to declare in this is it's about analytics, and analytics have predictive capabilities. The maps are effectively the PowerPoint of those analytics. They're the output of those analytics. So as we move forward, how do we make those maps popular? How do we make those analytics seen by more and more people? I've been an open data champion since 1998 with the formation of a website called Geographic. And the main value around that was that of data democratization. What I didn't realize at that point in time 20 years ago is that we also need democratization for access. In those early days, the data access was strictly through an FTP server. It was very simple, very crude, but also quite effective for a certain audience. Today, while I would argue a veneer of geography, a very thin veneer of geography, is available through popular apps that we use on our phones on a regular basis. These apps are primarily designed to maximize advertising revenue for those people putting in the content and provide driving directions. So those seem to be the two main use cases for the apps you would have on your phone. They do not begin to address the social, economic, or environmental needs and analytical functions that come with GIS imagery and imagery analysis methodologies. Conversely, our sort of what our bread and butter that we're all kind of comfortable with is sort of, I guess, so the old term was GIS on the web. Effectively, we're still doing that. Data catalogs and other sort of portal implementations, they remain, I would argue, niche for the general public usage. When I see my, well, my kids now are old, they're in their 20s and 30s. they aren't looking for maps unless they're going hunting. And even then, one of my sons, when he goes hunting, has a horrible, horrible time trying to find all this stuff through geographically enabled portals. So that being said, I think that's a good introduction, but I think the core of this discussion is how to make geography part of our day-to-day web usage and mass market implementation.
Thank you very much, Cameron. Well said. So now I'd like to introduce Don Sullivan from NASA to round out our panel today. Don's only on the phone today, so over to you, Don, if you're still there.
All righty, thank you. Can you hear me now?
Yes.
All righty, yeah, I've got to mute and unmute in two places here. So, good morning, all. I'm sorry about the lack of video. I'm on a NASA laptop and video is disabled. Would also like to preface this with all of what I'm going to be saying this morning is my opinion, my personal opinion, and is not necessarily the policy of NASA or the U.S. government. So blah 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 blah. In any case, have been thinking around the GIS world for a long time. Well, okay. Before I do that, technically I'm a system engineer. I work for the NASA Airborne Science Program in the Ames Research Center, Silicon Valley of California. So background: I first started doing GIS on the web when I worked on a program that displayed the USGS digital orthophoto quarter quads on topo base maps. This was I don't know, 94, 95, something like that. The browser we used was Mosaic, for those of you who remember this, and we had a CERN web server. In any case, that was horrible. All the geomanipulations were on the server. It was a nightmare, but we did it anyhow. I'm one of the authors of the first implementations of the web map service for the OGC. Lucien Plessa and Jeff de la Beauchardier were the other ones. I'm the NASA representative to the Open Geospatial Consortium Technical Committee, where I co-chair a few working groups there: emergency and disaster management, unmanned systems, aviation. I'm the chair of the U.S. delegation to ISO TC211, that's the GIS working group there. And when I heard about this maps on the web and maps as first-class citizens, I went, oh my God, yeah. So I'm here just as a champion. I think this is just an amazing idea that has been way too long in coming. I've been waiting for this for over 20 years now. So good morning all, and I'll go back to mute, but I'll be glad to answer questions.
Okay, Ted. Well, we haven't done a panel yet, so this is a first. So I guess we could probably entertain questions, but maybe if you want to type your questions, well, I'll ask a first question, and then if you have other questions, you could type them into the chat panel, and I'll repeat them, or you can raise your hand somehow. I'm not sure how that works on Zoom. So yeah, I have a question, Cameron. How if you were looking for the non-commercial information that governments can provide, like how do you see that how do you see that being happening on the web, and like non-commercial government information that could be provided in a way to make it more useful? How do you see that being, what's a scenario in which you could see that being useful?
Well, I like to think of it in terms of something that a person might do in their house that has nothing to do with geography. Like they have a task to do. A household has a task to do. So I've noticed, I don't know what it's like in every other city, but I know in many cities in Canada, the real estate market has just gone nuts. I don't know if it's due to COVID or whatever, but the demand exceeds the supply. So if I wanted to go buy a house or a cottage right now, how would I do that? And I know how I would do it. Even as a geographer, knowing about all this great stuff, I would just go to my favorite browser and I would start searching for a house. And let's say that house is in a different city to make it a bit more interesting. So I know nothing about where I'm looking. I just know I want to be in a certain area for some reason. So I would, and my family laughs at me because once I get on a browser, I can have 20, 30, 40 tabs going. They're actually surprised the browser can still work. And you get, so what are you searching for? Well, I have this area of interest to buy a house or a cottage. So I'm looking around that area. But what are the values of those properties in that area? What is around the house? Is there a factory behind it? Is there a school behind it? Is there a toxic dump behind it? Or is it a beautiful park? Is there education for myself and family to go to? What's the crime rate? What's the access to health facilities, retail and public transit? And before you know it, you've got all these very small tabs on your browser open and you still don't have a map. I have nothing to actually guide me as to all these options. One, as I said earlier, the PowerPoint of the analysis, something I can show my family, here it is. I can't go around showing them 20 or 30 tabs. So imagine, where now I can just drag one tab onto another tab, drag and drop basically, and it will build up a visual representation of my research. And I can say, oh, look, I found this place and I found that place. This one's got a beautiful park. This one's really nice, but there's no hospital nearby. And this is what happens. So I see that as one scenario where, the general public would just, I think, eat up, the fact that I can just create this synthesis of my research in a map form rather intuitively being driven by the browser engine instead of me having to do some sort of plugin. We also see other examples. We do a lot of work in the Arctic. It's very important because this is the poles are being devastated by climate change. So how, and the people that live in the Arctic, in these remote communities, learning about geography and APIs and all this stuff is the absolute last thing on their mind. They're dealing with, serious health issues, employment issues, clean water, very, fundamentals of life. So being able to serve that community, because
somebody on the chat pointed out that, there's portals like Zillow and realestate.com available for like house search. And I guess that's true, but I guess it doesn't apply to, well, it might not be as relevant for the Arctic, for example, for things that you're looking for in the Arctic, because I'm not sure they're on Zillow for one thing.
Yeah. No, but there's more than real. But I guess what I'm suggesting is even with, we have real estate sites, of course, but you can get to that real estate site. But then what do you get? You get a listing. It's not showing what the hospital is. It doesn't say if there's a children's hospital. It doesn't say if I don't get mugged when I walk out the door. You want all this ancillary information, and the question is how to easily combine that ancillary information.
Right. Okay. Another question that's come in is, what is the role and ultimate need of government in regards to mapping on the web? And so maybe I'll hand that off to Sébastien from the Canadian Geospatial Platform.
That's a good question. Just so to give some context, the platform does provide a stepping stone and answers the need from maybe half of the government departments and agencies. So that's the number of contributors we have. We are in the process of onboarding almost all of the provinces and territories also, just at least to gather information and then share it. But after all that, I think that to answer the question is, I would first want to go with what is the role of government in all this, and how do we, and the role of government is to administer. That's certainly an easy fact. Now the question is, how does the government administer? Technically, you actually define rights, restrictions, and responsibilities on features through time and space. So you kind of set up the framework that way. Now, what's unique about government is that we can legally define information as law. So that information becomes authoritative and really provides an ultimate framework that can, shape decision-making and operations. The ultimate need of the government is to be able to leverage such ultimate framework. So now the platform moves into the cloud, for example, and we're trying to establish all that properly, but build analytics over that framework so that we can then render authoritative map products. And I think the best example for that is COVID. Having a count of your local area on COVID cases is very pertinent, but everybody wants to see where's the hotspots, how does it go in time, what are the trends, so that you can actually represent properly the epidemiological situation associated with COVID. So that perspective requires actually an integrated perspective. It requires an effort from a coalition of groups that actually built on authoritative data to deliver something that is usable. The question about something that Jonathan mentioned before about data being not used or sometimes not really used I think it's not really the question. We want to make the data out there available, but what we're missing is we as technical experts, technocrats or geospatial experts, we need to bring the products up to a point where it becomes a viable entity that can be consumed by anyone. And that's what actually makes the system work. And we see the OGC doing a fair amount of work from a backbone standpoint, but in the end, this whole environment ecosystem, like I'm a biologist from background information, I know that if you cannot duplicate yourself, if you cannot grow and spread your genes, you're not living. You're just a rock waiting for, decay. So that living capacity needs to be provided through the mapping experience from the back end up to the front end whole experience. So the need of government from a mapping standpoint is to be able to connect to what matters so that we can deliver the right information in a consumable way to the users. That is, to me, the real challenge.
Okay. Thank you for that. I guess I would encourage the other panelists to chime in with editorials on the panel responses.
I'd just like to add a point to that, what Sébastien just mentioned about the role of government. So if we consider, what's popular on the web, I'll be honest, I use Google Maps a lot when I have to go find something. I'm looking for a supplier, I'm looking for a restaurant, I need driving directions, there's an accident on the road, it's great for that. And that's all, and a lot of that's monetized through advertising revenue, in that case, Google or whatever the platform is would receive. But government's responsibilities are very broad. As I mentioned, economic, social, and environment. And government is not monetizing through advertising. Government monetizes through taxes. So in order to meet, what the voters want, ostensibly. So how does the richness of all that data around, especially the environment, society, and economy, make it into mass market applications? I think that's a fundamental question for government.
So, okay. I have a question for Dawn from the audience up through the Getter channel. Are there special needs and requirements for maps for NASA, like timeline dimension and so on?
Okay, I'm sorry, I wasn't quite catching that. Timeline dimensions, repeat the question,
are there special needs or requirements for maps for NASA, like timeline dimensions or other things?
Boy, okay, so that could be answered so many different ways. There certainly are time-sensitive dimensions to almost everything that we do. We're primarily data providers, although in the airborne science program, where I spend most of my time, we're data consumers, primarily of aviation data. We've got to visualize it really, really quickly and accurately. So yes, there certainly is a temporal domain to it. I'm still not exactly sure where the question's going, but yes, and again, I'll speak now to the airborne science program specifically. We live with data that is temporally defined and both produce it and consume it. So if you could elaborate on the question a little bit, I'd be glad to go where the questioner was heading.
Okay, well, let me see if there's more information.
And Peter and Don, I can probably compliment that one a little bit. Because I was starting to talk about the Arctic a little bit earlier. And one of the goals we're socializing right now is the notion of a 6-dimensional Arctic spatial data infrastructure. So the 6 dimensions would be X, Y, and Z, but based on any coordinate system, including discrete global grid systems, which can also link well into MapML. And Z can be anywhere from, geology right up to the atmosphere. The other reference systems, of course, the other dimensions are time, obviously for change detection. The next one is any scalar vectors. So anything with a direction and magnitude. So I'm thinking currents and migration would be in that. And the sixth one is what I would call gray literature. So the whole bibliographic community around scientific literature and how is that, because they all have a location as well, and how would that be incorporated?
Right. Well, I guess in defense of the MapML specification, we tried to pay attention to the WMS and WMTS use of dimensions. So you can, in theory, query the map source at any value of a discrete dimension that is provided as a select list, and I'll go through that in my breakout. But so there's a question about is it the cost effectiveness of maps in HTML or versus API implementations of it. And I think that the question is more, and I'll put it out to the panel, is it, I mean, I think the idea of maps in HTML is to make it simple, like the simplest possible interface to get a basic map going. And the idea behind that is not to choose between APIs and client technology, but to have both, to make them work compatibly. And so would simplifying the developer experience, let's say, at the low end, or at the entry level, would simplifying the entry level make a difference to the consumption of your services? Is that something that would be of interest and valuable for your business, your use cases? And maybe I'll put that to Emilio.
Yes, thank you. I was thinking that one problem, at least for us, when your web services are free and open, is that sometimes we don't know very much about our clients, because yes, we know the number of requests, but if you don't have information in the user agent or these fields of the HTTP protocol, it's impossible to know some very important information of our clients. And this is a difficulty that we suffer with our services. And I would like to say something about authoritative data, because always mapping agencies talk about that our data are authoritative, but I think that it is not enough. For instance, if you use a topographic map from our National Geographic Institute, and finally you are lost in the forest, we don't have any, there are not any legal implication. So that our data are authoritative is not enough. It is important the quality and the updating of the data. Other thing is for cadastre data. In this case, in Spain, the cadastre data are not only authoritative, but are legally binding as well. So I think that this is an important aspect of government data sets and services.
I'd like
Yeah,
to
Peter, this is Don. If I could pipe in for a second here.
Yes, please.
Just a thought, and again, maybe I'm off base, and the rest of the panelists and folks online would correct me right away if I could, please, or if you would, please. But I'm looking at this as not being really an issue of authoritative or who has it or monetizing it. And again, maybe I'm being very simplistic, but I, as a consumer of geographic data, visualizing in a browser, I'm really tired of having to deal with, am I going to use Leaflet or CartoDB or MapShup, and how am I going to do the rendering, and so now we already have a system where in Airborne Science we've got a visualization toolkit, a common operating picture system that we ingest regular web services. Well, we really need, other services. We really need threads. So now we've got threads in there too. And I would love to be able to write something really simple in HTML with a map tag or something like that. And I thought that's kind of what this whole thing was going to. So correct me if I'm wrong, but if we could just take the abstraction up to the very highest level, and aren't we talking about making it simpler and getting rid of a lot of these questions, moving them into different layers of the picture? What am I missing?
Sébastien, I'll let you answer.
Well, I'm actually would like just to resonate with this. I think this is actually a crucial requirement. That's what I was trying to do with the opening statement a bit. 90% of the newly acquired data is georeferencing, as georeferenced. So we should, by default, try to facilitate their depiction of the depiction through a map capacity on HTML, through HTML. Make that barrier as simple as possible. The reason is, from my standpoint, as to why this is important, we have a limited amount of geo resource and technical expert within our organization, and trying to sustain the communication requirements associated with all of these data, whether or not they are authoritative. We can't even make a nudge to the domain. It's like saying, let's trying to, it's a communication tool. That communication tool should be as simple as possible. And because most of the information nowadays is geo-enabled, HTML should be directly geo-enabled. That means have the capacity to show that information. That's the bare bone requirement in my perspective.
I mean, I guess the only editorial I can comment, try and combine what Don was asking with my views that the user is the integrating person, the element in this architecture, right? Like HTML is made for users. It's designed for accessibility. Elements bring features that users need to interact with the content. So, I mean, it's not that you can't do these things in script or in programming. It's that the common facilities that users need can be built into the language of the web. And so, you know, maps are very much a user-oriented thing, and I think that we need to think about the difference between thinking about it, things like APIs and services, and thinking about a facility in HTML is the difference is the user, right? In an API and a service, you're thinking about the user being a programmer. Whereas when you're thinking about providing something in HTML, you're thinking about the user is the person sitting, consuming the thing that you're producing. And so that's the difference. So I think it's a mindset thing. So web developers are thinking about that user when they produce, ideally, they're thinking hard about that user when they produce their websites. But we have the HTML layer that we have, in theory, access to at design time. And so I think that what the Maps for HTML initiative is trying to do is to get the geospatial community to think about how can we bring the factors that affect all users when using maps into that common framework, and let web developers should be able to enhance that, but we should think about how people consume maps and spatial information at the standards level as well.
And just to comment a bit more on Don's point. So Don, I believe you started when you started. You said you didn't think this was related to the data reliability or authoritativeness of the data and to monetization. I agree with you that I think that authoritative data, this is just another channel. So the data is either authoritative or non-authoritative with or without MapML. The monetization point, though, I think the point around that is, you know, the very popular web interfaces we see today are based on advertising. And I think but as I said, that's just a veneer of the data. So how do we get all the other data, you know, the rest of the iceberg available in an easy to use format? Just as sort of you said, like, no, you really can't expect the average user to start playing with Leaflet or whatever. So why isn't this just a simple browser query and integration within the browser? It should be that simple using, you know, simple languages like HTML.
And I just want to add another thing there about the comment about authoritativeness of the data. I understand it's not the topic of that discussion, but it is important when you put yourself in the shoes of anyone trying to make a map for whatever reason. If they can have confidence in the product that they will produce, that is important. And at the DG level, or when I create something, they all want to know where the information comes from, so that they can have confidence in the product. So that concept of authoritativeness or legally binding data is actually quite critical, and should be conveyed throughout the application down to the end user. But in a nutshell, even if you have the best infrastructure around with all that authoritative data legally binding, if you're not enabling the users to easily create those products on the page, it's again, bottleneck in communication. And again, COVID, I was pretty engaged in COVID this year and trying to provide a Canadian response through the different departments. And I can tell you that making those maps were extremely painful. It was a painful process, and just try to find the proper ways to do the communication, making sure that the map products, but also the dashboards and all those things were actually meeting requirements from WCAG assessment, the Canadian government web template, and all those things. These are the type of hurdles we have to go through when we want to push any information out there to the public. We need to make sure it is consumable, meets all the laws, but we have to do it relatively short, like in a short time fashion when it's to address and answer a crisis such as COVID. So that brings back even more the requirement to have a simple, well-vetted, integrated solution that is ideally directly supported by the browser developers, so that we can just, okay, let's rely on that thing. It is really a standard. It's not a schema or whatever. It is a standard for all to depict, like it's the go-to way to make a map on the web. And that would be a big, big, big uplift on our capacity to connect, interpret, and make the information interpretable, and give the tools and ammunition for anybody who has to communicate something important through the web, give them the tools to do so. Anyway, my perspective again.
Yeah, no, I completely agree, and also I want to make sure that I'm not leaving a perception that that I'm saying accuracy is not important, or you know, some sort of quality metric is not important. Sébastien and Cameron, please, I did not mean to say that at all. As a matter of fact, I would suggest that we reconsider our traditional metrics for accuracy. I mean, you know, we deal with you know, where's it on the ground, or in 3 space or in 6 space, and so we're going to use the geological surveys plus or minus 40 meters accuracy, or we're going to use the firefighters. I mean, I deal with wildfires and imaging fires a lot, and the accuracy metric I got from them is don't put the fire on the wrong side of the road. So now we're talking plus or minus a meter, absolute accuracy. So I think we need to rethink that. There's a group in an organization called ESIP, the Earth Science Information Partnership, that is looking at that whole issue, and they've come up with what I consider a really novel and valuable approach, and it's an operational readiness level. So it sort of abstracts the idea of accuracy and you know, and data quality into usability. You know, is it good for this group, or is it good for this group? And that's an orthogonal issue to maps on the web, but it's certainly important. So again, I wanted to make sure that I wasn't perceived as denigrating accuracy or quality in any fashion, other than saying that it was orthogonal to putting it as putting a map as a first-class citizen in HTML. So I wanted to get that in before the end of the panel. I wanted to make sure that I wasn't leaving the wrong impression. My apologies.
No, that's good. Obviously, coming from NASA, if accuracy doesn't matter, would have issues. Yeah.
Okay, well, I think the panel has about run its course, but I would like to extend my thanks to Emilio and Dawn and Sébastien and Cameron for being willing participants in the discussion. And I'm going to hang around on Gitter for a long time, another 2 weeks. So anyhow, I hope that they will tune in on Gitter as well, and potentially interact with other members of the audience there. So I'll be posting links to the presentations and the discourse discussions about those things. So those are good places to make comments about those presentations for the authors to get feedback about, and to answer questions or whatever. So if maybe I'll just poll the program committee if they have other words, but I think we're pretty much ready to close at this point. Hearing none, I will thank everyone for participating today, and I look forward to chatting with you online.
Thank you, Peter. Thank you, everyone.
Thank you.
Yes,
Thank you, Peter.
Alrighty, thank you all. Have a
Thanks, Peter. Great job.